Okay, this is part two of our discussion about recognition. Remember, we're trying to talk about models that describe how we make this basic recognition judgment, how we decide what's old from what's new. And now we're going to talk about dual process theories. So, dual process theories argue that there's two memory signals. So, with signal detection theory, we saw that there was one memory signal, memory trace, and it varied on a continuum from low to high. Here, in dual process theory, there's actually two memory signals. So the first one is called familiarity, and this is described as a sense of oldness without any specific context. Now, Manler, an early theorist, sort of used an example he described, like when you see your butcher on the bus. The butcher's out of context, he's not in the butcher shop, and you see a familiar face, and you're like, oh, I know that guy, but I don't know where I know him from. That's the idea. If you've ever had that experience where you've seen somebody's face, and you're like, I know that person, but I don't know where I know them from, then you're having that pure familiarity kind of experience. Now, under dual process theory, familiarity forms a continuum and it can be modeled using signal detection theory. So all that stuff that we learned about with D prime and the criterion and all that, that applies, but that applies to familiarity. Where dual process theory differs is it says, hey, we have this other thing called recollection. And recollection is its own memory signal. This is when you remember specific details. Either it happens or it doesn't happen. Now, you could remember one particular detail, like you see somebody's face and maybe you remember just their name, and that's the only detail you remember about them. Well, you've recollected their name, but you haven't recollected any other details about them. Another case, if it's somebody you really know really well, you might see their face and recollect lots of details about them, and you have lots of information accessible for them. But for each detail, the recollection either happens or it doesn't happen. And it can be modeled using sort of a threshold kind of thing where you either the details either happen or they don't happen. Or another way to think about this is familiarity is kind of like an analog signal where it varies in a continuum and a gradation of strength, but recollection is like a digital signal where it either happens or it doesn't happen. So the idea is which theory is true, and so we're going to talk about some evidence for these theories, and there's competing opinions on this, and the field goes back and forth, and the signal detection theorists, they'll present evidence suggesting that model works better, and the dual processing people will present counter evidence or a counter way to sort of interpret that evidence. So I'm going to just sort of summarize what's been happening over the years in terms of trying to generate evidence for one or both of these theories. So in terms of dual process, you can have people make subjective ratings where they give R or K judgments. And this comes from Indel Tolving, and where he sort of said, you can tell people, hey, give a remember response when they remember a specific detail about the encoding experience. So for example, we're talking about words that you either heard in a male voice or a female voice. If you remember which voice said it, well, that would be a specific detail, and that would indicate that you recollected something or you remember something and you give it an R. In other instances, when you just know it's old, you're going to give that a K judgment. And so R judgments map onto recollection, K judgments map onto familiarity, and it's a subjective people reporting on their own experiences. Now, the bottom line is you can do some experimental variables, and those experimental variables can change R judgments and leave K judgments alone, or vice versa. They can alter K judgments and leave R judgments alone. And that evidence is sort of evidence that they're dissociable. These two states are dissociable. And if they're dissociable, then that leans towards a dual process interpretation. The problem with that, though, is it's been criticized for being too subjective, that like maybe people aren't in touch with their subjective experiences very well. So another way to quantify this is to use a source memory test, right? So in this case, people are hearing information in a couple different voices, or they differ in two different characteristic ways, but now they're just asked to report the correct source. And the idea is that if you can report the correct source, then something must have been recollected. At least one detail must have been recollected, the source of the information. Whereas other situations are just cases of familiarity. And again, variables can selectively change source judgments without affecting recognition, or vice versa, and this has been evidence of dual process. But the reality is, and you can look this up if you want, the reality is you can interpret this behavioral data in either way. And it does. It goes back and forth, and people will interpret this as, no, it's consistent with signal detection, no, it's consistent with dual process. But let's talk a little bit about, or let's compare the theories first, and then we'll talk about some neuroscience evidence to support them. So the idea here to compare these two theories, the single process, which signal detection is a single process view, meaning there's only one memory trace. So familiarity and recollection happen, but they're experiences. They're experiences from one memory signal at two different ends of the continuum. That's the idea, or the crux of the idea behind single process views. Dual process views say, no, familiarity and recollection, not only do they happen, not only are they different experiences, but they result from different memory traces. Furthermore, familiarity can be modeled with signal detection, but recollection cannot. It changes things quite a bit. So one piece of evidence that supports a dual process view over the single process view quite clearly are ERPs. So first I have to tell you a little bit about, before we talk about the evidence for it, we got to talk about what it is. So an ERP is when you record electrical activity of the brain. Well, that's known as EEG. And I have an ERP lab at the College of New Jersey, and this is an example of what happens is you put these electrodes across the person's scalp, and you record their brain activity while they're doing some sort of memory experiment, like a recognition study, and you record their activity. Now you time lock to an event. In this case, you would time lock to when the word is, and you average across to get what's known as an event-related potential, or you're extracting signal from a bunch of noise. So what we can do is we can record when somebody sees an old word and calls it old, and when somebody sees a new word and calls it new, and we can look at the ERPs, and that gives us a measure of the processing differences between when an item's old and when an item's new, and we can examine these. Now, to sort of summarize this literature, essentially you can create experimental situations where you're looking at just familiarity, and when you do, familiarity creates an ERP that begins pretty early, 300 to 500 milliseconds, and it's right in this area right here. So we see the FN400 with an arrow pointing to it. Now it's a frontal ERP, so and it's the old is more positive than the new, so that's called like an old new difference, this FN400. So it happens right around 400 milliseconds, and it's frontally located, so it's called the FN400. So this is the sort of the ERP at a particular electrode. The F3 electrode is a frontal electrode, and this shows you a topographic plot. So it's like you're looking at the person's scalp maps from above. And so their nose would be up here, your left ear would be over here, right ear would be over here. And this plot sort of shows you the old-new difference. So when you take old and subtract the new, if you get more positive values, it's going to create that reddish color here. And if you get more negative values, it creates the bluer color here. And so you can see that it's concentrated, this old-new effect is concentrated at the mid-frontal electrodes and is indicative of familiarity. Recollection, on the other hand, when people recollect, you get a little bit later ERP, 500 to 800 milliseconds. It's parietal for words in particular, and it's sometimes called the parietal old-new effect. It also goes by the name late positive component, or LPC. So the LPC, as you can see, is concentrated in a different region. So it's a different region and time frame. So it occurs later and a different location. And so the idea here is if these were two different ends of one spectrum, then why would you have two different ERPs for them, right? So the idea is if signal detection theory is right and it's just one memory signal, well, then you shouldn't be able to differentiate between familiarity and recollection in terms of timing and location. But here we get these two different ERPs. If you have two different ERPs, that suggests that there's two different memory signals. That's why it's strong evidence for dual process views. I'm also going to give you a link in Canvas to a paper that discusses this in more detail. This is the 2007 Rugg and Curran paper. So if you didn't totally get what I said here, you can read that paper, maybe come back and listen to the description again. so it can make some sense. Now, similarly, fMRI has produced some similar results. And so, what's an fMRI? fMRI is when you record an MRI of the brain, and you can determine what areas are active by looking at the blood flow in the brain. So, to sort of summarize what's going on here, we can also create studies where people are making judgments based on familiarity. And when that's the case, you have this perirhinal cortex is active. And as you can see down here, the perirhinal cortex is indicated in the blue. So, here's the perirhinal cortex. When people are making recollection, right, so they're making recognition judgments based on recollection, you have the hippocampus, which is this red area here. Remember, that was the area that was damaged in patient HM. And also these left parietal areas are active as well. So these left parietal areas are active when people are recollecting. So again, this evidence suggests, because you have two different regions that are active, that's suggesting that there are two dissociable memory signals, or supporting that dual process view. If it was just one kind of memory signal, why would you have these two areas that are differentially active? At least that's the argument that people are making. So just to summarize all of this stuff and come back to a particular piece, because we've seen this sort of come up again over and over again. And that is, what does this hippocampus do? Remember, this was the area that was damaged in patient HN, and we saw that it was really important for forming new memories. So one study that looked at this by Rick Adante, who is a former TCNJ student, went on and got his PhD, and what he measures sort of ERPs in patients with hippocampal damage. And essentially what they had is these are the control subjects engaging in a task, and they have that LPC, or that parietal old new effect, which characterizes recollection. But the hippocampal patients don't have that. So here you can see that in that same time window, they don't have that same recollection ERP. Now, of course, they have some amnesia too. So again, we're showing sort of a dysfunction of that activity. And now also, what does the left parietal activity do? As we saw in that slide before, if you're recollecting it, you have some parietal activity as well. So some hints to this, Ali et al., what they did is they looked at patients that had parietal cortex damage, so their hippocampus was intact, and their behavioral measures of like old new judgments, that was intact, but they didn't have that recollection ERP, so there was no LPC for them either. And they reported that it had a diminished sense that the event was personally experienced, right? So the idea here is that the left parietal activation is probably downstream from the hippocampus. So the hippocampus is necessary for it to happen, but it also does something by itself. And perhaps this left parietal activation is related to the vividness within recollection. So I kind of alluded to this before. You could have recollection, but in different degrees. This is something that Willingham called partial access, right? So you remember, and when reading that paper, him talking about partial access, this is what he's talking about. That maybe you recollect some details, but not all of the details, right? So you could see a person's face and remember only their name, but not remember what classes you had with them or other details about them. That would be an example of a weaker memory, weaker recollection versus a stronger recollection. So the question is there any experimental evidence that this left parietal areas is associated with vividness versus vague recollection? Yeah, there's two studies that, and actually there's a few more studies, but there's a couple studies that actually show this. So I and Michelle Phillips did a study where we had people do a source monitoring judgment. Remember, they're making accurate source judgments. That's an indicator of whether they've recollect, or some indicator that they have at least partially recollected something. We then had people distinguish between more vivid memories by making a remember judgment and a know judgment, and we found that LPC activity was different between those two conditions. Similarly, Vilberg and Rugg had people study items for either 6 seconds, which created more vivid memories, versus 1 second. And they found the same kind of ERP difference we did, and in addition, they did a fMRI analog, and they found that this difference in the left parietal cortex was greater here as well, both showing that this left parietal cortex is probably responsible for vivid recollection of the event, right? So this is something that Toving called as re-experiencing our memories, right? And it probably happens in the left parietal cortex. Now, to make another connection, if you read that Richter et al. Study about Nelson Cowan's theory, he's postulating that this is happening in working memory. So this re-experiencing is happening in working memory involving this particular area. So that's another interesting connection for you to make there. So just to summarize this, the hippocampus is necessary for binding information and creating recollection. So remember, when it's damaged, like with patient HM, that's not going to happen. But the left parietal cortex contributes to what Toving called the mental time travel, or re-experiencing the memories as we've had them before.